Moab, Utah. I'm a co-lead of the WISE network along with Courtney Collins and Kendall Beals, who you'll see in your Zoom screen as well. And we had a lot of feedback from folks that are in our network that our workshops would be really helpful. So this is our first one, and we're really excited to see how it goes and try this all out with you. So bear with us. We've never done this before. And then we're going to have 2 more. The next one is going to be on in March. On March, I'm not exactly sure the date. Maybe Courtney can chime in and tell us, but it's going to be March 17th. It's going to be about, it's going to be at the same time.
Sorry, March 18th.
18th.
March 18th, same time.
And it's going to be about integrating GitHub into your workflow. And then there's going to be one in April that I am going to lead. That's going to be about organizing your R projects into, or your R workflow into a package structure, just kind of getting things more organized and easier to work with and easier to collaborate. But today is going to be our Intro to R workshop, and it's going to be led by Janani Hariharan, who is a WISE member. She was part of our inaugural mentorship program, and basically we sent out some meeting minutes from one of our mixers that we have monthly that was saying we're going to try and organize these R workshops, and she awesomely emailed us and said she'd like to help and be involved. So we roped her into leading the first one. She just did her data carpentry certification, and I'll let her introduce herself a little bit more than that, but that's our brief intro.
Thanks, Michaela, and thanks to everyone from WISE, which for people who are unfamiliar is Women in Soil Ecology. Just thanks for taking a chance on me and just running with my crazy idea of, hey, I know R, can I do an R workshop? And here we are. So thanks for having the confidence and for organizing this and putting this together. And I'm so excited to see more and more people still sort of rolling in. So just to briefly introduce myself, I'm Janani, I use she, hers pronouns. And I'm a PhD candidate at Cornell University, where I study soil microbiology, in case it wasn't clear from my microscope earrings. Currently, I work on the biogeography of these cold bacteria called Streptomyces, which are responsible for producing that the smell that you get after rain, which is also called petrichor. And so I study them using their genomes primarily. And I'm interested in figuring out where they're found, why they're found there, and what factors sort of affect their spatial distribution. And as Michaela said, I'm going to be the primary person leading today's workshop, but I also want to let the other people who are involved in teaching as well as helping out with the workshop introduce themselves. So maybe we can start with Courtney.
Hi, I'm Courtney Collins. I am a postdoc at CU Boulder, and I am one of the co-organizers and co-founders of the WISE network, along with Kendall and Michaela. I will be here as one of your question answerers and leading a little bit of today's workshop, a very small section.
Hi, everyone. I'm Kendall Beals. Like Courtney and Michaela and Janani said, I'm a co-organizer of the WISE network, and I'm going to be leading the one of the data wrangling portions of the factors section when we get down to that. And I'll be helping out answering questions and stuff as well.
And Cassie, we should hear from you.
Sure. I'm not leading any sections, but I'm here just to support and moderate and help answer any questions that you all have. So if you have any questions, post them in the chat. You can also DM me directly if like something specific is going on that you need help with. So.
And just to shout out Cassie, she awesomely answered our tweet begging for help with getting some folks to answer questions. So we're really grateful that she was willing to volunteer to help out.
I feel like that's a good segue into sort of the logistics of how the workshop is gonna happen. So let's see, first things first, just some ground rules. So turning your cameras on is not required at all. We're not going to force anybody to turn their cameras on if you're not comfortable doing so, but we would really love if you're able to, that you have your cameras on just so we can see your faces. And it's really helpful to get that sort of nonverbal feedback from people as to how you're doing and if you're confused or if you're following along with what's going on. So if you're able to, we would really appreciate it. Thank you. I see so many cameras turning on already. It's good to see people. And as far as asking questions go, because we realized that coding, so we're going to be very hands-on. You're going to be coding along with us. So if you haven't already, get your RStudio windows open. And so we realized that hands-on coding can be a tricky process, fraught with complexities. So which is why Michaela, Cassie, Courtney, and Kendall are going to be your helpers for the first portion of the workshop. And so if you have a question, feel free to just throw that in the general chat to everyone, and one of them will respond to your question. Or if you don't feel comfortable doing that, maybe it's a very specific problem, feel free to just shoot one of them a personal message, and then they'll work with you one-on-one to get those questions answered. Any questions about the structure, how things are going to work so far? And since it's a smaller group, you can also feel free to just unmute yourselves if there are questions right now. Okay. Great. And before we start, I just want to emphasize I have two screens open. So sometimes it might look like I'm staring off into the void. I'm not, I promise. I'm just looking at my other screen where RStudio is open. So when I'm typing, I'm going to be looking to the other end, but my attention is completely focused on you, rest assured. And so that's another useful tip. If you do have two screens available, you might choose to have Zoom open on one screen so you can follow along with whatever we're typing, and then your RStudio open on the other, just so you can type with us simultaneously. If you don't have two screens, not a problem. We will make sure to pause and go slowly such that everybody can sort of type and follow along in their own time. And if you need a little more time to follow along, just let us know in the chat and we'll sort of adjust our pace accordingly. Great. With that, let me start sharing my RStudio window. Okay. Give me a thumbs up if you can see my RStudio. Great. Okay. So first things first, maybe I should give you a quick rundown of what we're going to be doing on RStudio today. The first hour is going to be spent sort of exploring the basic data structures in R, the different types of data that we can work with, how do we use those different data for different purposes. The second hour, we're going to start working with a real data set. You don't have to create a data set, we'll help you download one from the internet. And then we're going to get into a little more complex data wrangling, as Kendall put it. And then the last hour is going to be spent working with this package called ggplot, which is really useful for plotting figures in R. And if you've ever read a scientific paper, you've probably seen a figure that's been produced by ggplot. So it's just a very handy, nifty package to use if you're interested in data visualization, which many of you mentioned that you were based on our pre-workshop survey. So thank you to everyone who filled that out and gave us a sense of what your needs were. And so you can see my RStudio window. Let's just orient ourselves to the window for anyone who's maybe opening RStudio for the first time. So the big window that we see here on the left is the console, and that's where we're going to be typing all of our commands. That's where we're going to be seeing the output of all of our commands right here. And command, by the way, I should clarify, it's just a thing you want the computer to do, and then the computer gives you a response for whatever you told it to do. So think of it as speaking to the computer, essentially. Over here, top right, is where we see environment and history. It says environment is empty right now, but as we start typing, as we start doing things, we're going to see that getting populated with more and more objects. And we're going to talk about what objects are in just a second. And over here, bottom right, where you can see my cursor is sort of where, so it says files, and you can see a bunch of files that are currently on my desktop show up here. Plots, when we make plots, this is where our little figures will pop up, and so on and so forth. Never mind, we'll deal with that later. So first things first, in case you were not familiar with this idea already, R is actually a great calculator. So you can do really simple things, simple calculations with R, and you don't need any fancy functions. You don't need to know any fancy commands. You just type in what you want, it does the operation, and it gives you the answer. But I know that you all are here because you want to do more complex operations than that. So let's start by talking about what an object is. I just use the word object. So if you've learned other programming languages, you've probably heard the term variable. An object in R, for our purposes today, is essentially the same thing as a variable. So for example, and here's our very first command. If I do this, right? And you can see that something just popped up here on the global environment. And so what I just did is I created an object called weight_kg, and I assigned the value 55 to it. And so just to clarify again, weight kg is the object, 55 is the value. And this little arrow you see over here is just called the assignment operator. Some people prefer to use the equal sign. So if I did this, it would essentially have the same effect, but more often than not, you'll see this notation very standardly used in a lot of R code. And so I don't know, I prefer to use the error sign. If you prefer to use the equal sign, that's great. And so we just created an object, we assigned a value. And something to note with R is that you want your object names to be explicit and sort of clearly labeled so you don't confuse them with each other. For example, if I wanted to do 55, and then I was thinking of the weight for a different sample, which happened to be 20. The problem is weight, as you can see here, now became 20. Instead, if I did weight 1, which was weight for sample 1, 55, and weight 2 for sample 2 is 20, that still remains distinct and they don't get confused with each other. My code remains clear. So something to think about when you're naming your objects. I would also suggest avoiding dots in the names of your objects and using the underscore option instead, just because a lot of R functions have dots in them. And so you don't want R to get confused between the name of your object and an inbuilt function that it uses in the code. But those are things that I think you will sort of figure out for yourself the more you start creating objects and working with them and naming them in R. So when I did this, I'm just typing the same command out again, you notice that nothing popped up on the console, right? It just hit enter and then nothing happened. If I wanted R to also print the value of the object, I wouldn't do that. I would actually place the parenthesis at the end of the command. Good lesson. And now it tells me 55, right? I can do the same thing just by typing the name of the object too. So you can make R print out the value of the object when you're assigning the value just by putting it in parentheses. Or if you want to go back and check what your object is, what the value of your object is, maybe at a later time, just type the name of the object out and R will tell you what the assigned value is at the moment. It's also easy now that weight_kg is assigned as 55 in R's memory. It's super easy now to tell R to do different kinds of things with it. So for example, if I said this, so basically I'm just converting kg to pounds or lb. So I'm telling R, multiply this by 2.2. And then R tells me, okay, this is your value. And if I wanted, in the spirit of naming objects right, if I wanted to do this, you'll notice again, it doesn't print anything out because all we did was assign the value. But of course, if I do this, then it tells me the same thing, 121. So I'm gonna do this. Oops, sorry, I meant to type weight kg. So what I just did is change the value of this object, weight_kg, to 100. What do you think is the value of weight_lb now? And feel free to type your answer into the chat. And can one of the helpers maybe tell me what people are thinking?
Sorry, Janani, what is the value of weight LB? Is that the question?
Yes.
So far, we have no answers. Oh, we're getting answers. 121.
Okay.
still 121 because it hasn't been reassigned.
Yeah, so that's exactly it. So what we did is we changed the value of the object after we did that first operation where we calculated the weight in LB. So you can see that if I type weight LB, it's still 121. But if and you can see that I'm just using the up arrow to sort of run through my previous commands. That's another useful hack. You don't have to go back and copy paste or retype your commands all over. If you press the up arrow key, R will sort of iterate through all of your previous commands. So now if I go back and reassign weight LB with the new weight kg value, ta-da, 220. So just something to remember when you're sort of working with different objects is that just because you change an object doesn't mean that R is automatically going to update everything else that you did. So if you want everything to be updated, you need to make sure that you go back and sequentially update everything that's in your code. Many a mistake has been made this way, trust me. So we just started typing in a few commands, right? And a lot of times I will do this just to do sort of these instant calculations to check what's going on. But the super useful thing is that I want to be able to save my code and then come back to it later. For example, I do an R analysis today, I come back in 2 days and I have no idea what's going on. So it's helpful to save my code so that when I come back to my desktop in a couple days, I know what happened, I know exactly which commands I ran, and I don't have to sort of go back through up arrow everything, right? So the way to do this, and I don't know if you can see what options I'm selecting, but essentially I went up to my RStudio toolbar and I said File, New File, and R script. And you see that I have this script open here now at the top left that says Untitled 1. What I could do is click this little floppy disk over here, which will save it. And I want to save it on my desktop. So I'm going to say WISE Intro to R, Feb 10th. So that's my first R script. And if I wanted to save the commands that we've been using, I would say weight kg. And then I took that and I created this new object called weight in LB. I also want to introduce you to the hashtag, which is essentially what we use in R to comment on code. And comments are just like little notes that we write ourselves to, in my case, explain what the heck I did and what my code will do the next time that I open the file. So here I would say hashtag assigning weight in kg, hashtag converting weight to LB. And especially as you start to type code, bigger and bigger chunks, you'll want to use those comments to separate out different chunks of code and to sort of leave notes for yourself on what to use when and how does a particular chunk of code work. So commenting super useful. Also, if you're collaborating with other people and you're sharing your code with them and you want them to be able to understand what the code does without having to, sit with them over Zoom and go over every single line of code and explain what you did. So hashtags, super useful. Please feel free to use them during our workshop today to liberally annotate your R script and make sure you understand what's going on where.
Janani, do you want to just go over the opening up the R script one more time and the difference between the console and the script?
Sure. So the way I open the R script is File, New File, and you'll see a bunch of options that says Use R script, R notebook, R markdown. Our notebooks and markdown files are super useful. We're not going to be going into them today, but I just selected R script from the New File option, which is how I open this little window up top. And the difference between the console and the script is that, so when I type something in the R script, like for example, if I typed weight underscore kg is 55 and I hit enter, nothing happens because the script is static, right? It's not, R doesn't read my commands from the script. R does read or hear my commands from the console. So when I do the same thing, we see that weight underscore kg is actually assigned back to 55. So the script is a way to store and save all of your commands for future use. Was that clear, Courtney, or was there a more specific question?
That was from Robin. So think that was good. Robin?
Yes, good, thank you.
Sure. Great. Okay, so now I'm gonna have people, well, no, I think we've got that part. Sorry. Now we're gonna move on to functions is what we're gonna do. So I used the word function before, and functions are essentially these canned scripts, chunks of code that will automate parts of your workflow for you. So assume there's a single operation that you do over and over on all of your data tables, for example. Writing a function might be super helpful for that because then you don't have to type the same code over and over again, right? And R actually has a lot of inbuilt functions already. So for example, round is a function that R already has built in. So if I did round, for example, right? So round essentially is a function that I'm using to tell R to round up this value that I just gave it. And so it gives me a round number at the end of it. And so if you want to move beyond these base functions, is what we call them, the functions that come pre-packaged and pre-installed with R. If you want to move beyond them, we use what are called R packages, which are essentially just like extensions. If you're a board game person, you can buy an extension pack and you fit it onto your base R. And that sort of expands the number of functions that you have access to, right? So you can do bigger and better things, more specialized things by downloading and installing packages that are specific to your research area and your analyses that you're interested in. And so I just introduced to us the round function, and the point I want to make here is that some functions are fairly simple, some are not. So for example, sqrt is a function that will give you the square root of a number. So if I did sqrt 25, that's 5, and that's about it. That's the only value. So the function returns a single value. Versus with this round function, let's take a look at what the function is all about. And so what I just did when I typed in args is I asked R to tell me what arguments the function takes in. And arguments are essentially the different types of input that a function can take in. And depending on the input that you give it, the function will process your data in different ways, and it could even give you different types of output, right? So when I did args round, R tells me that a round is a function that takes in 2 arguments, x and then digits. And x typically stands for the number or the data frame or whatever type of object you give R to may have the function 1. But in addition to this x, which in our case would be 3.141567, round, it sounds like, takes also another argument called digits, right? And so if we go back and do 3.141567, and this time I say digits is 2, you notice that we get a different output. And so what I just did is I told that function that I want you to round this number down, but to 2 digits, right? Not 0 digits. And you can see that the default here is 0. By 0 digits, I mean the floating point digits, not like 0 digits in total. So anything after the decimal is removed by default. But this time what I did is I changed that default digits argument to 2. And so R now knows that I wanted 2 digits after the decimal point, as opposed to remove everything after the decimal point. So I'm just going to take a breather for a second and see if we have any questions about functions popping up in the chat.
No questions right now that I can see.
Great. And so as we move on from functions, I just want to leave you with one very useful tip. So in R, the standard is if you encounter an unfamiliar function and you don't know how to use it, the best thing to do is type question mark and then the function's name. So when I do that, we see our first event in the bottom right window. And what R just did is gave me all of the information about this function, right? So it says round is the function. You can see base in the parentheses. in the curly brackets. And what that means is that this is an inbuilt function in R. So it's part of base R. When you install R, round is a function that is automatically installed on your computer. And it gives you a description of what the function does. So it rounds numbers down. You can get a more detailed description of the function. Most importantly, it gives you the usage of your function as well. So you can go in here, you can see the same things that we saw with args, ARGS, except you can see a lot more detail. And this is essentially what I was explaining to you as we were typing. But if you don't have my voice in your head and you want to actually navigate new functions and figure out what's going on, the easiest thing to do is question mark and then the function's name. Okay. So we're going to move on from this idea of objects and functions to talking about vectors in R. So any questions at all about objects, functions, how to use them? Okay, not hearing anything, so I'm just going to go ahead for now. So far we talked about objects, for example, weight underscore kg, which is a single value, right? Vectors expand on that idea, and vectors are essentially a series of values, right? And vectors, the way we would define a vector would be, for example, if I did now weight underscore g, and this is standard notation for creating a vector. So we do C and then parentheses, which is how R knows that this is a collection or a compilation of a series of objects, right? And so I'm going to input 4 numbers. So for example, 50, 60, 55, and 45. And so when I do that, you can see over here in my top right window, weight underscore G, it says NUM, and then 1 to 4, and then my 4 values. And you can see that it's different from weight underscore kg, for example. So R recognizes this as a vector and not an object because of that C and parentheses notation that I just used, right? So this is a vector that we created with just numbers, right? Vectors can also be created with characters or words. So for example, if I did mouse, rat, cat, and dog. And what you'll notice, I did something different when I created the character vector as opposed to the numerical vector. I put everything in double quotes, which is how R recognizes strings or basically bunches of alphabets put together. So that's really important because if I didn't do that, if I tried to do, for example, mouse, rat, cat, dog, no double quotes, R tells me error, object mouse not found. Because if I don't put my string in double quotes, R thinks that it's an object that it's supposed to find and not a new word that I'm sort of introducing to R, right? So when I go back, I did up, up, and I did animals, and there we go. So it has the double quotes, R knows it's a string. It doesn't try to search for the object mouse in its current environment. So hopefully that's clear. So we just created 2 vectors, weight underscore G and then animals. So how do we examine vectors, right? How do we work with them? How do we understand their dimensions? So one simple function is called length. When I do length, it tells me, as you can guess, the length of the vector. So I had 4 numbers over here. You can see I'm highlighting weight underscore G. And so R now tells me, hey, you have 4 things in this vector that you created. And if I do length animals, I should see the same thing because I put 4 strings inside the animals vector. The other function I want to introduce you to when you're working with vectors is called class. And we just saw that vectors are a collection of objects, but then these objects can be of different types. We created numeric and then character-based vectors. And so if I want to know if I have an unfamiliar vector and I'm asking R, hey, what type of objects are in this? How do I know what type of vector it is? So when I do class weight G, it tells me that's a numeric vector. There's integers or numbers in it. And when I do animals, it tells me that it's a character vector, right? And that's important information for me because integers and characters, I will use different operations for them in R, depending on what type of objects are inside the vector. So it's helpful to run that on the vector and have R sort of give you a sense of what type of objects are in it, what size is the vector, and so on and so forth. The other thing you can use if you want to do if you want to get a lot of information simultaneously, every time somebody enters the waiting room, my default window changes to Zoom. And so I have to tap on RStudio to get it back again. So when I just did SDR, which is essentially structure, when I do SDR and then I put the name of the vector in, you can see that R gives me a lot of information, all of the information that we got through those individual functions so far. So it tells me that it's a numerical vector. It tells me that there's 1, 2, 3, 4 objects. And then it also tells me what the objects are in and of themselves. So that's a nice comprehensive look at the vector if you're just examining it for the first time, for example, right? And so again, character vector, 4 objects, name of objects. And the thing is that vectors are also very dynamic. So just because you created a vector, it doesn't mean that you have to stick with it for the rest of eternity. If I wanted to change So if I wanted to add an animal to my collection of animals here, what I would do is, what animal do we want to add? Rabbit. So let me just explain what I did here. I'm telling R that I want to add this character, rabbit, or the string, rabbit, to animals, the pre-existing vector animals. And then I want to save it to the same vector. And let's see how that works. Yep. And the order in which I added that is important because I said animals, rabbit, animals. So you can see that rabbit now popped up first before the other animals that I had added, right? So what if I did it the other way around? I want it added to animals, but I want animals first and then hamster. So do you see what happened? Everything in animals got printed first and then hamster got added to the end of the list. So you can move things around in the vector depending on the order in which you add objects to the series of objects. Was that clear what I just did, adding objects to the vector?
And folks can also give a thumbs up reaction if they don't want to respond in the chat or don't have their video on.
Yeah. Okay, great. I'm seeing some thumbs up. Oh, I just figured out how to maximize the little participant window. I can see everyone again. Great. So yeah, we just figured out how to add objects to existing vectors. And so if you're working with a real data set, you can keep doing this over and over again to sort of expand your collection of vectors, to keep adding things as and when you need them, right? So there are many different types of vectors in R. We just saw 2 types, numeric and character. There's also, for example, a logical vector that just has true and false. So the Boolean logical is the sense it's being used in. There's something called a complex vector that represents complex numbers. So we have real and the imaginary components of numbers. So yeah, there's a few different vector types, but the character and the integer, the numerical ones are the ones that are used most commonly, especially in ecological analyses. So we just introduced ourselves to those types of vectors. And one last vector function called type of weight G. And that tells you that the type of the data structure inside this vector is a double, which is just a fancy way that R tells you that it's a floating point or a decimal point number.
We do have a question in the chat that I think might be good if you have a second to go over. The question is, how can I add the object in the middle of the vector? which I
that's a
think,
good question.
yeah. Go ahead.
So we can talk about that when we get to the section about subsetting vectors, I think, which is what we do to pull out objects from specific positions in a vector. So if you can hang on to that question for just a couple more minutes, we'll get to that. But before we move on to subsetting, I want to give people something to think about. So we created two vectors, right? But you saw that the types of objects in both vectors were the same. So we had one vector, which is these numbers, and we had one, which is the strings. So what happens if we try to add a string to the weight underscore G vector? Or if we try to add a number to the animals vector? Maybe if somebody who's coding along wants to try that on their computer. And
We have
show.
an answer, it becomes a character vector.
I see. So the first one, weight underscore G, becomes a character vector.
That is the answer that's in the chat.
Okay. And what about the other way around? What happens if you try to add a number to animals? So how do I do that?
We have a response from someone. It says it stays a character, and someone else says it doesn't work for animals.
It doesn't work for animals. Can the person who said that maybe elaborate what they mean by that? Why doesn't it work?
Feel free to unmute too, and Naomi, perhaps, or
Yeah, so when I tried to add 2 to animals, it told me a non-numeric argument to a binary operator.
Oh, interesting. To a binary operator. That's interesting. So you can see that when I did the same thing that Naomi did. So I said, I want to add 4. I didn't put the strings around it to animals. It changed 4 to an object with the double quotes. So it basically changed 4 to a string, right? So this is a fundamental rule in R that vectors can only be of one particular type. So when we try to force R to take objects of different types and combine them in the same vector, it does what's called coercion. So it changes the object type that isn't consistent to an object type that makes it compatible with the rest of the vector, right? And it isn't automatic like we saw. Like for example, when someone tried to add a character to the weight underscore G vector. So let's see. So I have trying to add I don't know, cheese to weight underscore. I'm bad at spelling today. Yeah, and so you see that everything became a string, right? Everything that was a number before is now a string. And this is because R has an implicit hierarchy in which it converts one format to another. And I'm going to post that in the chat, but this is the order of coercion, essentially. If I can find the chat. There we go. So essentially anything that's logical, so true, false gets converted to numeric, so 1 and 2s. Anything that's numeric gets converted to a character, which is what we just saw with the weight underscore G. Logical gets converted to character as well, depending on the type of the vector. So logical can either be numeric or character, depending on what objects already exist in the vector, for clarification. And so I think that hierarchy is important to think about when you're working with different vectors, because if you try to coerce, if you try to add an object to a vector that is inconsistent with the rest of the vector, R will sometimes do funny things. And so if you go back and think about the hierarchy, you can usually figure out what just happened and what you need to do to get things back on track. So important lesson with vectors there. So let's move on to thinking about extracting specific objects from these vectors, right? We saw how to add objects to the beginning and the end of vectors. But somebody asked a question, what if I want to work with the middle of the vector, right? What if I just don't want to pull things from the ends? And one way to do this, and this is what we call subsetting, and this is just a common sort of term in R. When you see those big square brackets, it's usually subsetting something, whether it's a vector, whether it's a data frame, whether it's a table, whatever it happens to be. So square brackets mean that you're subsetting, and subsetting is essentially pulling out a specific thing in a specific position from your object, right? So I did animals too. And when we look at animals, you see that rabbit was the second word in there. So when I did that, so basically, oops, I got muted there for a second. Sorry. So when I put in the specific position that I'm interested in, R just gives me the output from that position alone. And the thing to remember here is that R is what we call a one-based language. So the number, the count of positions in the vector starts from 1. So 1 is 4, 2 is rabbit, and so on. And that's an important distinction because this is something that's different between sort of languages that are more intuitive to humans. So we start counting at 1, right? Versus computers start counting at 0. So if you work with languages like C, for example, the counting starts at 0. So R is not one of those languages. And so that's important to remember when you're pulling things from specific positions. We're going to start at 1 and go from there, not from 0.
Janani, I might pause you. Nicole had a common issue that happens. Her caret got switched to a plus in her console.
Caret, do you mean the arrow?
Yeah.
To a plus.
So
That actually hasn't happened to me. Has it happened to one of you?
So does anyone know how to get, well, I just told Nicole how to do it, but does anyone know how to fix that problem when they get stuck in the middle of a line of code?
Oh, I see. You mean when you were typing and it just added a plus. Got it. Yeah, does anyone know how to fix that? Okay, that's a no. So Courtney, how did you help Nicole fix this?
So you will just press the escape key and it will get you out of whatever line you're stuck in, and it will bring you to a new caret, which you can start a new line of code there.
Yeah. That usually happens when, for example, I've missed a parentheses, for example, and R is like, oh, you did something I don't understand, go back, fix it. So yeah, just hit escape, start from the beginning and retype your line of code. That usually works. Thank you, Courtney. Okay, great. So we talked about creating vectors, subsetting vectors based on particular positions, right? But what if you want to subset a vector not based on the position? Maybe you don't even know which position you want or which object you want, but you know which conditions you want to use, right? So one way of subsetting it is by using the Boolean vector that we talked about. So the true, false. So for example, if I did animals, C, because I'm doing a vector, so I do true, true. How many objects do we have? 7. 1, 2, 3, 4, 5. And so what I'm doing here is I'm telling R, this is my Boolean vector. So true, true, false, false, false. And I'm putting in 7 objects in there to correspond with the number of objects that are in my original vector. And let's see what happens when I do that. So you can see that R just gave me 1, 2, and 4. So 4, rabbit, and rat, because those are the positions that I specified as true, right? And so this is helpful, for example, when I've worked with 2 different vectors and I want to pull things from one vector based on the conditions from a second vector, if that makes sense. So I can get like, I don't know. So for example, I have one vector with say temperatures and I tell R, hey, tell me true if the temperature is above 50 degrees, and tell me false if the temperature is below 50 degrees. And so it would give me a Boolean vector like the one I just put, right? So true, true, false, yada, yada, yada. And now I take that output and then I feed it to my other vector, maybe that has like species IDs. And I say, I want all of the species that I spotted at temperatures about 50 degrees Celsius. So using that same vector, I can now get only the objects in those particular positions, right? So another way of, oops, remove caps lock. Another way of subsetting, if you have a numerical vector, for example, it does that. So I said, hey R, if an object in weight underscore G is greater than 50, tell me it's true. If not, tell me it's false. So this is an example of how you might get a Boolean vector that you want to use on another vector to get those particular positions out, assuming that things are ordered in the same way, right? If you want to get the objects themselves and not just the true, false, I'm going to subset. So I'm using the square brackets that we saw, and I'm going to do this. Whoops. Of course, I misspelled the name of the vector. Oh, cheese is greater than 50. That's interesting. And I forgot that I made that a character string. So of course, things are all messed up now. So what happens if I make this 50, 65, 45, and 70? So it's, what did I do? Whew, okay. There we go. This is what I wanted to show you. So I have a numeric vector, no characters messing up our numerical values. And so what I just did is I used my condition. So weight is about 50, and R essentially gave me all of the values instead of the true, false, if you're not looking for Boolean vectors, right? If, for example, I was interested in all weights that were larger than 50, but say lower than 65, I could also do that by using an operator. So I could use the AND operator, and I would say, I want everything that's greater than 50, but less than, I think I said 65, 65. And it says, well, there's nothing in that range, right? Because 50 is here and 65 is here, but there's nothing in between. What if I did is less than or equal to 65? And then it would give me 65. So that was using the AND operator. If I use the pipe instead, and let's take a moment to locate the pipe because some of us might not use the pipe very often. So if you do shift and then click your /, the pipe should be on top of the /. But take a moment to locate that on your keyboard. So the pipe is our stand-in for the OR operator. And so I say, weight is greater than 50 or weight is less than 70. And so now it gives me everything, of course, because all of the objects in that vector satisfy these conditions. And then I say now 65. Right. So this time it should give us everything because it's not an AND, it's an OR, right?
Janani, can you go over the pipe again?
Sure. So the pipe is the OR operator. So for example, this command that I just typed, what I'm doing is I'm telling R to subset anything in my weight underscore G vector that is greater than 50 or less than 65. So it's not an AND less than 65. It can be either greater than 50 or less than 65, right? Which is why we get all of these values. So 50 is less than 65, 65 is greater than 50, 45 is less than 65, and 70 is greater than 50, right? So if I change the pipe to an AND, nothing, because there's nothing between 50 and 65, right? Does that make sense?
Yeah, I think that's good. And then maybe some people also know that there's like there's another like kind of little thing that you can do called a pipe that like subsets from data. So there's two different things that we're talking about, a different kind of pipe here.
Yeah. Oh, that's true. Yeah. That's a different pipe. Thanks for the clarification.
In the dplyr package.
Sometimes I call this one this one that you just showed or I call it a bar, which helps me determine between the two sites. But I don't know if that's a good. I just made that up. So
Yeah. So if you have been using other packages than R, then you know there's a different pipe that is essentially like.
and I think we'll get into that. There's parts of it later that have this pipe, which we'll talk about.
They do different things. Okay. So for the person who just asked us about how to insert an object in the middle of a vector, did we figure out how to do that? Or can anyone help answer that question maybe, now that we've talked a little bit about subsetting? Actually, I'm gonna stop sharing my screen so I can see faces. Any answers? Or do any of the helpers want to chime in?
I do it in a clunky way, so I would be curious if other people have good suggestions. I normally just like caret the row column, but
Yeah, I think factors are more, you use factors to kind of give order to a list like that and not a character class object. So I think factors would be the way to go.
And we are going to get into factors a little bit further on, where we'll show how to order them in a certain order.
Yeah, for factors, I often use the levels and relevels command to order them, which I feel like that's what I end up ordering the most, because I'll go to make my figures and I want things to come out in a certain order and they don't.
Sorry.
what would be your suggestion, Janani?
I also do it in the clunky way that you mentioned, which is why I was hoping that somebody would have a more elegant answer. But yeah.
I have a question, I guess, about like a way you could do it. Could you say like, say you've like a vector like animals and it has 8 things in it. Could you say like animals like arrow C, and then animals 1 through 4, and then like comma the thing you want inserted, and then animal 5 through 8?
Yeah, you could do that. Yeah. Thanks, Nicole. I'm going to turn it over to Courtney to lead her section on missing data.
Awesome. Thanks, Janani. You've been really so polished on this, so I will try to continue. And here we go. Let's see. So I am going to hide this because I'm going to type for you here. So because R was made to analyze data, specifically, that was kind of one of the main intentions of R, the R language. R wants to let you know when your data is missing. And so rather than just having a blank cell like you would see in an Excel file, where you just have no value in that particular cell, R is going to code something as an NA. So NA meaning not available. So anytime you see the term NA, that means you have a particular cell or location in your vector or data frame, which we haven't gotten to data frames yet, but we will, that has missing data. And so I am going to remove, I had already created this height, so I'm going to remove height from my global environment, which you can see here. Can everyone see my screen? My R console? Okay, so here's a little quick tip. RM, you can remove anything from your global environment. And it's not called height, it's called heights. So we are going to remove it. And now my environment is empty. So that was just a little precursor. So we're gonna think about missing data, how to find missing data, and how to get rid of it, and how to analyze a data set with missing data in it. So we're going to make something called heights. And this is going to be a vector with 5 values. So 2, 4, 4, and then I'm gonna code in this NA. Normally I wouldn't do this, but we're just making a kind of little vector to play with, but maybe you would load your data and you would have missing data. So if everybody wants to create this heights vector here. And so we can see that this height vector has 5 values in it, and one of them is an NA, or a missing value. And so when we want to run some type of function on this, R is going to kind of know that there's a missing data value in this, and it's going to throw you off a bit. So if I were to ask R, what is the mean of heights? Does anybody have an idea of what might be the answer to this?
We have NA would be the answer in the chat from a couple people.
Nice. And that is correct. So I am, maybe I can, is it helpful if I just type in the console? So I am typing up here in this R script, and then my answers are coming down here in the console. So can people see that? All right, cool. So, whereas Janani was just typing directly in the console, some people were asking about that. So we can see, yes, correct. Mean of heights is NA, and that's because there is this NA value in there. So R is, that's gonna just supersede everything else in terms of what data is in there. We can run another function like max heights, same thing, NA. But a lot of times you're gonna have missing values in your data set. I mean, we all have ecological data here, and where we have missing data.
And I just let everyone know in the chat, but just when if you import like a CSV or an Excel file and you have blanks, those will come in as NAs.
Yep.
So you don't have to write NA for everything. I actually prefer to just have the blanks and it reads them in as NAs.
Yep, anytime you're gonna import a data file into R, which we will do in the next section, if you have any blank cells, they will automatically code as NAs. Sometimes they will code, I don't know, a little weird, but most of the time they'll automatically code as NAs. That's something you also want to check for. Thanks, Michaela. So we're not going to go in and take out all of these NAs manually. So does anyone have an idea of what we might say to R to let it know we want to use the numeric values in this vector and not pay attention to the NAs?
NA.rm.
Awesome. So this is one of our arguments that we can put into this mean function. And so as Janani was describing earlier, mean is a function in base R, right? So we can say here, we can try this and say, what does mean mean? And let's try it again. So it's going to come up in my help. So this is telling me I'm taking the mean. And if I look down at arguments in mean, na.rm is an argument here. And so that's saying, what should mean do with your NAs? Most functions will have this na.rm argument. So we can say na.rm equals true. We want to tell it which data set first before we do that, or which vector. So I'm saying take the mean of heights and remove .rm, remove the NAs. And so that value is now 4. Everybody cool on that? Do the same with max.
It's good to note here too that in the help file it says na.rm is a logical, which always means that it's like true or false. And that can be helpful when you first start reading help files. They can be really overwhelming.
Yeah, and so I can put a T here, or I can write the word true. same thing. The max is 6, the mean is 4. What would happen if I put na.rm equals false? Any ideas?
Someone wrote still get NA as the answer.
Awesome.
And that's cool. In the help file, it'll show kind of above arguments. It shows NA RM equals false. And that's just because it defaults to false.
Yeah, great. So this is the default, right? So that's why when I don't put this NARM argument at all, the default is not to remove the NAs. And so the default is going to be throwing it back in NA. So I need to tell it, remove my NAs. Tell me what's the max value. Cool. So what about if I want to stop having to add this NARM every time I do something? Maybe I just want to like take this heights vector and make a new heights vector without any NAs in it so that I can work on that one. So this is something that we're going to now extract our data and rename it. So we are going to say heights. And again, I sort of did a little note to this in the chat earlier, but when I start typing, it's gonna try to auto-populate with anything that's already in my console. And so it got it correct this time because I only have one thing. If I had more, I could scroll down and choose the one I wanted, and then I can tab for autocomplete. That'll save you some time when you're typing. So I'm gonna say heights, and I'm gonna rename heights. So I'm gonna fill over the heights vector I already had. And I'm gonna say is not, I'm gonna use this first. And I'm gonna say is not, exclamation point, is not, is dot. So what is this gonna have in it? Right, it's gonna have everything in heights that is not an NA. And it is not happy with me. What did I do here? What am I doing wrong here? Do I want these? Maybe I don't even want those. There we go. Nope. Oh, okay. So here's an example. Because I wrote it this way, it's telling me which of the values of heights is an NA and is not an NA. So is not an NA true? Is not an NA true? Is not an NA true? False. That one was, and this one's true. That's not what I wanted to do, but I'm giving you a good example of what might happen.
In your first one, because you're subsetting, you just have to have heights written before, like the first one right under the 6. Where it says heights and then you have assigned, you have to write heights on the outside because that's what you're subsetting. So the brackets are the subsetting.
Thanks. I don't know.
That's one of the reasons
in base R.
That's one of the reasons we do this with the type where we type everything out so we can make mistakes and you can learn from them.
Awesome. So did everybody see what happened there? Does anybody have any questions about why I got true falses? Great, because I was asking R to tell me which of these is not an NA. Now what I'm saying to R is subset from heights, which of these is not an NA. And so now if you look at my heights vector here, I have only the things that are not an NA. Something else I could do is, and I do this a lot, is let's say I want to go back and know where those missing values were, right? Maybe I'm going to call this heights no NA. So I know what I did here, right? I could have just renamed it, and so I filled it over. But now I have 2 vectors, one that's the regular one with the NAs and one without. And so now as I move forward and running my scripts, I can just use this heights no NA, and I don't have to do that NARM equals true, right? Because those are out of there now. So this is now the vector I can use for some of my downstream analyses. Pretty cool. All right, and then let's see here. So we learned the is not command here with the exclamation point, and then is NA. So what if I did this? That would just give me an NA value, right? Because I'm saying take out which ones are NAs. You don't want to, you probably won't use that as much because typically you want to get rid of the NAs. So we are going to use the exclamation point, but know that the exclamation point means is not. So it's kind of asking you to do the opposite of what the function is.NA is doing. So we have heights, no NA. Then we have max at 6. Another way we can do it is to say NA dot omit. And on this one, you don't need to put that heights first. You can just, I believe, yes. And now it has rewritten over my heights. But again, I didn't want to do that, right? So I'm just going to go back, remake heights again, put that NA back in there. And now I'm going to make there. So this NA.omit command is equivalent to this is.NA with the brackets. So it's kind of up to you which one you like more. I tend to like the second, which is why I got the first one wrong first time. Any questions?
So there's one question in the chat that says, can you treat NaNs in the same way as NAs?
So NaNs are not coded in R as NaN, they're coded as NA, I believe.
They'll come in if you work with sensor data, like coming in from a CR1000, sometimes you'll get NaNs.
How do those get read in?
They read it like it says NaN, which is basically not a number. I often just assign them as NAs just so everything is NAs, but I think that someone can correct me if I'm wrong, but I'm pretty sure that R reads them in the same way as NAs. No. Okay, never mind. Someone sitting in the room with me said my partner's no. It must read them in as a character. So I usually
it would read them in as a string, right?
Yeah. So there's a special data type for NaN apparently. You can do is.NaN.
Just a general tip when you're
Awesome.
entering like data manually before you put it into R or a software program, I just always put in missing data as like NA. And so then when I'm working in R, I automatically know that I don't have to change those NAs to something else.
Yes, or as Brandon just mentioned, is.NaN is actually an option, which I have never seen, so thanks. So let's go and back to our heights and make a dummy NaN. Here we go. So heights is now going to have NaN instead of NA. And then we're going to say heights, no NA. Let's say no NaN just for consistency here. And then we're going to use that is not NaN. Right, so this is an option. This is an option. And same thing. So I don't know if NaN omit is a thing. NaN omit is not a thing. So you don't have two options there. You only have the is.NaN option. So Kendall, now you don't have to do that. I learned this too. Okay, awesome. Great question. Any other questions? Cool. So one of the last things is we're going to think about something called a complete case. So a complete case is basically something that is a logical vector with no missing values, right? So we can also just say here, heights what would happen here if we ran this complete cases on heights. I guess that's what happens. I don't typically use this function that much, but yeah, so that's when we're gonna find out about whether things are true or not. If they are, no, wait, am I doing this right? Sorry.
You need to
Yeah.
do the subset part again.
So you're definitely learning how to not
this-
do it.
This is a question that's been coming in the chat a lot, getting true and false. So if you just run complete cases on the object and reassign it as that, it will return to you this logical that will tell you which of the columns in the original heights is NA and which isn't. So by putting the heights in front of the brackets and so the brackets are the subset, the straight brackets. So that's saying in your heights data frame, subset only the complete cases of heights. But if you run it first without the brackets, then it's reassigning heights to be a true false. And then you have to start over by reading in the first line of heights, which is one thing that I think Janani talked about in her first part was like, unique names can be good. Like if you have something and you don't necessarily want to overwrite it, maybe name it heights 1 or something like that. And that way you don't run into that problem.
Right, so here I'm gonna call this heights complete, and I'm gonna say out of heights, take the complete cases. So something that is not missing. And again, heights complete is the same as heights no NA and no NaN. So these are just 3 kind of different ways to skin the same cat. And that is kind of, it's really just your preference. I typically use the na.omit. They all work. And yeah.
But I think the complete cases might be good for folks dealing with the NANs because it can handle that. Whereas I often don't do that. I'll like reassign all the NANs as NAs, which is a little bit clunkier. So learn something new every day.
Any other questions? Cool. Thanks for learning with me. And yeah, so we can save this here. Again, we're going to save as, and we're going to save this as NA tutorial. And now I can come back to this anytime and work on my NA tutorial.
Thanks, Courtney. I want to make sure that folks have a chance to stretch, maybe get some tea if you want, use the bathroom, do whatever you need to. So let's maybe take a short break and meet back here in about 4 minutes. So my computer says 1:16 Eastern time, whatever time that is for you. Let's meet back at 1:20 Eastern time. Okay, I am seeing people start to walk back to their computers. So I'm gonna give it maybe 30 more seconds because I still see some gaps in the video. How's everyone doing energy wise? Give me a thumbs up or a thumbs down or a medium thumb. Ooh, puppy. Excellent. Seeing a lot of thumbs ups.
That's R.
Great.
We have a lot of dogs in this house right now, so there could be many dog
Please.
cameos.
We can do the puppy cams.
Please hold up the dogs to boost energy levels.
We have 4 of them at the house currently, which is as many dogs as people.
Excellent. Okay, so let's get started with part 2 when we're going to start working with a real data set. And this is a data set that we're going to download from the internet. This is something that Data Carpentries typically uses for a lot of their lesson plans. And so I'm hoping everybody can see my RStudio again. Let me know in the chat if you can't. I just shared it. And the command that we use to download a file from the internet, thank you, someone give me a thumbs up, great, is download.file, right? And download.file, so you can see that R automatically prompted me. You see the little pop-up that came up when I typed download.file. So it's sort of telling me, hey, this is the syntax. This is what you need to tell me in order for me to download a file. So URL and dest file is what we're going to use for this particular file. So URL is me telling R which website to pull this file from, and then dest file just stands for destination file. So how do I want to save this file on my computer? So for URL, and I'm going to type this in the chat too, so that you don't have to painstakingly copy everything from my screen. But the URL, I'm going to ask you to, let me put this in the chat as well. Oh, you can ignore the quotes at the end, but that's the URL I want you to go to. So let me type that in. So I tell our URL is this, make sure it's a single double quote. And because it's a string, we're going to put the URL in a pair of double quotes. And then you saw that R said dest file, and you can see, like Courtney said, R will sometimes prompt you. So if I do dest file, and here again, string double quotes. So I'm going to give it what's called a file path. And a file path is essentially telling R where you want the file to be saved on your particular computer, right? So for me, I want this saved on my desktop. And so I'm going to type this tilde over here, the sign that I just made, which I can't highlight for some reason, but that wiggly sign that I just made, it stands for home. So in any file path, if you put that tilde, it just says home to the computer. And then any sort of directory from there onwards, you can just type in the path. So when I do that, oops. Aha, I see what I did. So I said destination file, but I just gave it a directory. I just gave it my desktop, and I didn't tell it how to save the file, right? So what I need to do is give it an actual file name. And so I would actually recommend that everybody saves their file with the same name so that we can use the same code. But I'm going to save it as portal_data_joined.csv. And for people who might not be familiar with CSV files, you can open them in Excel. So it's just like an Excel spreadsheet, except that they are comma separated files. So downloaded 2.9 MB. And I'm going to give people just a few seconds to be able to do that. And hopefully download the files to whichever directory you're working in right now. And once you have the file downloaded successfully, maybe give me a thumbs up so we can. How are we doing? Okay, I see one thumbs up. So at least one person's been able to save the file. Okay, one more. Good, good, good.
Mine is a like, such file or directory.
So in the destination file, did you give it a path on where to save the file?
Yeah.
And did you give it a file name too? Can you type your command in the chat and then we can sort of debug it?
That same thing happened to me, and it was because I had set my working directory already. And so even though I was trying to save it to the desktop, it wasn't letting me because the working directory was something else. So I just deleted desktop and it worked.
Yeah, so I should have said that. You might be working inside a specific directory already. Great, okay, now it works for everyone. So if you want to just remove all of those, the tilde and the file path and just put in the file name alone, it should save in whichever directory you're currently working in. Okay, thumbs up, yay. Thank you, person whose name I can't say, but who I'm very grateful to. Great, okay. So it looks like more and more people are figuring it out after that path issue was solved. So hopefully everyone has the file downloaded wherever they're working right now. So now we're gonna install and load our first package. So the way you install package is install packages. R is a very readable language. It's a very intuitive language, I think, for humans, as opposed to some programming languages. So the command to install a package in R is install.packages. And then it's install.packages tidyverse. Okay. And so I talked about how packages are like extension packs for games. So it's not just enough to buy the extension pack. You also have to open it and set it up. In the same way, downloading or installing the package alone isn't enough. You also have to load it into your current R environment. And so the way we do that is by using this command called library. So when I do that,
Janani, can you describe what the little stop sign means when that pops up? What does the stop sign mean?
oh, sure. Yeah, you saw a little stop sign pop up here. That tells me that R is working on something. There's a process running in the background. And if I want to kill the process for some reason, it's not what I want or it's taking too long, then I can click on the stop sign and it will abort the process, stop it from running. And so when I typed library tidyverse, you can see that R did a bunch of things. The most important thing we need to know, ignore these conflicts and warnings, they're not relevant right now, is that it attached all of these different packages. And we're not going to be using all of these packages. I just want us to be able to use a couple of functions from this package, tidyverse. And so I asked us to load them. So hopefully we've been able to download the file and we've been able to install and load the tidyverse package into R. If not, please type in the chat and someone will help you get those things done. So the file that we just downloaded, portal_data_joined, is now living and breathing on our desktop or on whichever folder you downloaded it into, but it's not in R yet, right? And so what I'm going to do is I'm going to use this function called read_CSV, and we know it's right, R immediately popped up and gave me a bunch of options. And I'm using read_CSV because we saw that the file that we downloaded was a .csv file, right? And so I'm going to say read_CSV type whatever file path your file exists in. So for me, this was the path that I downloaded it to. So whatever you typed into that destination file double quotes is what you'll want to put in here. And then actually that's it, nothing else. I just wanted to read this file. What I wanted to do is also save it in an object, right? So I did. So let's just recap what happened. I used the function read.csv to read our file into R, and then I saved it into this object called surveys. And as soon as I did that, the Tidyverse package gave me a bunch of information about the file we just read in. So column specification, calls, and these are all the columns and the types of data in each of these columns in the file we just loaded. So there's record ID, month, day, year, plot, species, sex, height, foot length, et cetera, et cetera. So clearly this is some ecological data. Maybe you're looking at some animal counts across different plots, and then they recorded different metadata about whatever species or whatever group they were observing. And then for each column, you'll see that it also gives you the type of data. So double, as we know, is a decimal point number. Character we're familiar with. So it also gives the types of data in those columns so that you know which column has which type of data. And so if you're playing around with different columns, you can be careful about that, right? Because we saw what happens when we try to mix and match data in vectors, for example.
How did you get the columns to show up? The column specification? Was there a command for that?
No, when I did the read_CSV, it just did that. Do you read _CSV or read.csv?
I did read.csv.
Yeah, that makes a difference.
Thanks.
Read.csv will just read it and not give you the details. But if you do read_, it gives you a summary. Great. And so what if I want to look at the object I just created? I'm going to use this command called head, which just gives me the top few rows of the table that we just loaded. And so you'll see it's called a tibble, which is just a type of data frame. And a data frame is essentially like a table, right? It's very much like an Excel spreadsheet. So you have different columns. Each row is an observation, and each column is recording a specific type of data. And the thing about a data frame is that each column can only be of a particular type in the sense. So you see over here, double character. So species ID all has to be character. We can't mix and match and insert numbers and characters in the same column. So that's something to be mindful of with data frames. And for our purposes today, a tibble is just a type of data frame. But there are some subtle differences that you might want to learn if you use Tidyverse a lot and if you're working with tibbles a lot. But so head essentially gives us the first 6 rows of our data frame here. If I wanted to get the bottom 6 rows, you guessed it, I would do tail. So tail parentheses surveys. And so this is just a quick way to sort of explore what our data looks like, to make sure that everything has been read into the right columns, because sometimes you can get data sort of misplaced in different columns and so on. So just a sanity check to make sure that everything is as it should be. And if you want to explore the surveys object in a more Excel style, you can do view surveys, and you can see up here where my script was, this like table just popped up, and it also lets me filter. For example, if I wanted to filter and say, I want everything collected in the first 6 months, it would do that for me in a much more sort of GUI type way, a graphic user type way.
Janani, we had a question. Someone asked, can you go over what you assigned to the surveys object?
Sure. So let me pull up that command again. So this is what I did. And what I'm doing is I'm telling R to read a CSV file. So that is read_CSV. And then in these double quotes, I put in the path to the file that we just downloaded from the internet. So that path might look different for different people, depending on where your file is stored. But as long as you type in the same path that you put for the destination file from our download data command, you should be able to read in the same file. And so what R is doing is it's just reading that file, that CSV file, and then converting it to a data frame, and it's storing it in surveys. Is that clear? Okay, not sure who answered the question, but if you have follow-up
Yes.
questions, please type them in the chat. Great.
We got a yes, thank you in the chat for that question.
Perfect. Okay. And then, so we did view surveys and we figured out how to explore that in a more interactive way. Yeah, so we've been looking at, once we've created a data frame object in R, how can we explore it? We did head, tail, something you could do. So we did this for the vectors as well, if you remember. We used the str or the structure command to get the details of the vector. I can do that for a data frame as well. And it gives me sort of a more detailed look. So it says record ID, but then it also tells me the type. It tells me how many entries are in a particular column. I can do DIM, which is dimensions surveys, and it would give me this. So based on the output of SDR surveys, which everyone was hopefully able to get to work, what is the class of this object? Surveys, and how many rows and columns does surveys have? And feel free to type it in the chat. Anyone?
Answers 34,786 rows and 13 columns. Oh,
Yeah.
well, you have that. Okay, sorry.
Great. And so the way that, so this is an important point, because when you look, when I did dimension surveys, we got two numbers, right? Which were both the numbers that Michaela just mentioned. But in R, the default format is always rows first and then columns. So whenever we're working with data frames, that's a constant syntax, rows and then columns, right? So which is why we have 34,000-ish rows and 13 columns. And this is important because just as we talked about subsetting or pulling out specific values from vectors, we might also want to subset data frames, right? And so when we're subsetting data frames, it's important to subset them in that same order, rows and then columns. So the way I would subset a data frame would look slightly different, because a vector just had one dimension versus data frames now have two dimensions, right? So what I'm going to do is I'm going to put in two values, right? And let's see what happens when I do that. It just gives me one. So it gives me the value in the first row and the first column. If I wanted to do, for example, the first element in the sixth column, this is how I would do it, right? So how would I do it if I wanted to subset the first column of the data frame? I'm hoping that someone in the chat will have some ideas. I want to get all the rows, but just the first column. Anything in the chat?
Yeah, we have one response. Vidya suggested using brackets and then a comma and then one and then close bracket.
So like this,
Yeah, something that looks like that.
like this. See what happens. Lydia is right. So we got just the first column and we got the first 10 rows, and R tells us that, you know, hey, this isn't everything. I have a lot more rows, but I'm just giving you the first 10 for now. And so we would do the same thing in reverse if we wanted first row, but all columns. And so that's what I get. And so it tells me there's 3 more columns that I haven't showed you, right? What about if I wanted just the 6th column, but the first 3 rows? How would I do that? And I can't see the chat. so I'm
We
not-
got some answers in the chat that were open bracket 1:3, 6 close bracket.
Mhm. Yep. And that's what I get. First 3 rows, just 1 column. The one last thing I want you to hear about subsetting is this cool idea that we can also use negative numbers for subsetting. And what happens when we use a negative number is that we subset from the last column or the row, as opposed to counting from the first column or row. So what I'm doing here is I'm saying, hey R, I want all rows, but only the first column from the end, right? And so, wait, what did I do? All rows, the first column from the end. Oh, I'm sorry. I got that completely wrong. I'm telling it to delete the first column is what I did. My bad. My bad. I got confused. Yeah, so I'm telling it to delete just the first column. So when I do head surveys, you see that the first column is record ID, second is month, day, year. But when I did this, it gave me all the rows except record ID. And so we're starting from the second column. So hopefully that makes sense. If you want to ever delete columns or shuffle them around, then feel free to play with that minus value in there. Any questions? Because I know that might have been a little bit confusing.
There is a question. Can we try subsetting with the with logical function, something like only if it is greater than a value or something like that?
Yes, I think you can. And that actually leads me to, what if I want to subset a column based on not just the number, but the name, right? So I know, for example, that species ID is a column. And so I say coats species ID, and so it just gives me species ID. I can also do this using the ampersand. So species ID, and you can see that R sort of automatically gives me all of the different column names. And so if I do that, oh, it's a lot. And what you see is that the structure is also different. So when I did surveys, square bracket, species ID, it looks like a data frame. But when I did surveys, ampersand, species ID, wait, that's not the ampersand, that's the dollar sign. I'm so muddled, excuse me, dollar sign species ID. What we see is more of a vector, not the data frame arrangement that we saw before, even though it's the same data, it's presented in different ways. So that's also helpful to think about when you're coding and working with different data frames. And so for this person's question, let's go back to the data frame structure. So we have record ID, month, day, and year. So say I want all observations that were recorded after the 15th day of any month, right? How would I do that? Surveys, day greater than 15. Let's see if that works. Survey day, 3. Maybe what I need to do is say, so this is just one column. So all rows in one column? Is that what needs to happen? No. Does anyone know what I did? Helpers, please.
Is it the extra brackets?
I think you're missing a comma after 15 because that denotes row.
Oh, you're right. And then I wouldn't need this. Yeah, thank you, Cassie. Yep. So yeah, row and column. So rows and then all columns. So yeah, and you see that it's basically filtered based on the column day, and any value that's about 15 in the column day will pop up, and we have all the rows in there. So hopefully that answers the question in the chat.
Yes, it did.
Great. Okay. Here's a challenge question. for people who are following along, could you create another data frame from surveys that's called surveys 200? So this is the name that I want, with just the first, the data in just the first 200 rows of surveys. How would you do that? I'm actually going to type what you tell me, so I'm ready.
So one person says, just making like a new object, surveys _ 200 equal sign or caret, and then surveys open bracket 1:200 comma close bracket. 1:200. Sorry, Johnny. And then
No.
comma, yeah.
And then comma, right?
Yes.
Okay. So let's introduce ourselves to a new function called nRow, which what that does is it counts the number of rows. So let's see if this code works by counting the number of rows. 200 rows. And just to make sure we also grabbed all of the columns from the original data set, we're going to do ncol, number of columns. So there's 213 columns. Great. So that worked. Good job, person in the chat. Any questions about data frame, subsetting data frames before Kendall leads us on to factors? Okay, I'm going to stop sharing and Kendall can take it away.
Thanks, Janani. Okay, let me just share my screen. Okay, can everybody see my RStudio screen? Yes, good. Okay. Okay, something that I might just mention that we didn't talk about previously is that my screen is, my RStudio background is kind of blue. It's a different color than Janani's. Courtney's is also a different color as well. So if I like using just a darker color because it's easier on my eyes if I spend like hours coding at a time. So if you want to change that, you can go into Tools, Global Options, and then there's various things here. You could go to Appearance, and then there are just a lot of different options of what you could choose. So that's just kind of something you would click Apply. So that's just why mine looks, the background looks different, but the boxes are still in the kind of the same places. Okay, so we're going to be talking about factors. And so when you're working with a data frame, like a table in R, you obviously want some columns of data. You want them, you know, you collected data on like tree heights or something. So you want those as numbers. And then some columns, maybe you had different kind of watering treatments. We were doing a drought experiment maybe. And so you have a column that says one of these, you know, this specific replicate was a drought replicate and the other one was ambient. And you want those coded as like categorical. And so that's kind of what factors does. It is, it allows you to tell R to say that something should be as like noted as a specific category. And so we're going to continue working with the surveys data frame, which I have kind of loaded in here. If I click on this, it will pop up and it will just kind of show me what the table looks like. This is an alternate thing to do as opposed to like typing view. You can just click on the object in your global environment and it will open in like a separate little tab. Okay, so if we wanted to go into that surveys kind of data frame, and we wanted to change like if we look here at the, we look at the sex column here, we have males and females. And if we wanted to change that into a factor, what we would do is we would type, we would say within the surveys data frame, and the $sign is going to say like what column within that data frame you want. And this will pop up. You can either type the column name or you can just like click on it. And then I think Cassie mentioned this cool little shortcut. Instead of manually typing out the caret function, if you press Alt and then minus sign, if you're on a Mac, it will just automatically pop up. So that saves you like 1 or 2 seconds. And then we want to turn it into a factor by using the function factor. And then we want to say the specific column within that one as well. Okay, so I'm typing up here in the actual script, and then the console down here is what's popping up, the output. Okay, and so then to check on that, you can use the summary function. I'm just going to summary function, and then looking at that column in there as well. Okay, and so then you'll see down here in the console, we have females and males, and then it tells you the number of individuals in that one. Okay, and so we talked about how to kind of like sort if you want to change the order of that, you know, the order of things that sometimes can be useful. So R just automatically puts everything into alphabetical order. And that's, I use kind of ordering a lot when I'm making figures, because sometimes I want things to appear in a different order in a plot or in a figure. And so that's when I use it, but you can also use it if you're just like working with your data. And so if you see, like if we just created a new, oops, oh no. Sorry, everybody, what just happened? Okay, sorry, I think I accidentally minimized my window. So if I just wanted to create a new kind of just like string here to just kind of demonstrate that, I'm just going to create a list here of factors. I'm just going to say male, female, male, female, sorry, slow typing. Okay, and so I just created a vector here that has factors with these 2 levels, male and female. And if I type out, if I want to say like how many levels are in that vector that I just created, it's going to pop up my console at the bottom where it says you created a vector called sex that has 2 levels, female and male. You could also, if you wanted to count the number of levels that you have in category, like this could be really useful if you have a bunch of categories, right? And you're not going to manually go through and count those. And so you could say n levels, which means the number of levels for that specific vector, that column. And then within this vector you just created, there's only 2 levels, male and female. So that's what it pops out as 2. And so if you want to reorder them, you can use this kind of parameter called levels. And so let's say we just want to reorder that. And so what we're going to say is factor and then of the same vector. And then we're going to say we want the order specifically equals to be, instead of it being alphabetical of female listed first before male, we want male to come first. And so we'll do that. Okay. And so now those, if we type that in again, okay, so now if we look down below, it'll say the levels of this, they pop up as male, female. And that's in the order that we want, as opposed to the order of female, male. Okay. I guess in the sake of saving time, I'll just go on to converting factors, but there is a challenge question if people want to do that. Does anyone have any questions so far?
I don't see any in the chat.
Okay, great. Okay, so now if we want to kind of work on converting factors, so obviously sometimes you want numerical data, right? You don't want this to be recognized as a category. And so in that case, you're going to have to convert the factors into like numeric values, for instance. And so there's a few different ways that you could do this. I'm just looking at my other screen here because these are kind of my directions. And so one way that you could do that is you could use the like as.character function. If you want to convert to a character vector. Okay, so now it converted back into characters, as you can see down in the console below. If I wanted to, you could also do that using the levels function. So let's just kind of create, let's create a vector string that just has like lists of years. So we'll just call this like year factor here. And we're just going to create something as a factor so that we can then change it into something else. Okay, so my vector string is, maybe these are years, 1990. Maybe these are births. I was born in 1990, 1993, 77, and 1990 again. Okay, so these are all factors here. But because these are years, we would prefer for these to be in numbers, right? And so one way that you can do that is you can use this function called as.numeric, meaning you want to make a vector or a column as numbers. As.numeric. Level. Year, FT. Brackets. Year, FT. Uh-oh, error. It says could not find. That's because, okay, so if you get an error, oftentimes it's because you've misspelled something. So I didn't add an S after levels. Okay, and so now you see my console pops out as these are recognized as numbers. And so what this function does here is it's basically going to convert it into all of these that were factors into numbers there. Did I miss anything? Yes. Okay. Does anyone have any questions about converting into numbers?
Nothing in the chat.
Okay, I'll keep going. Okay, so let's say we want to actually rename the factors. So if you want to,
I actually just got two
oh, yeah.
questions in the chat right after we said nothing in the chat.
Okay.
The first one is, why can we not do as numeric, open parentheses, year underscore FCT, close parentheses?
Yes, you can do that. So if we did that, if we just typed in as.numeric, year FCT. So if you do that, and then you'll see that like what I get down here of my output, it says like 3, 2, 1, 4, 3, right? And so it's just assigning those as numbers, because what it's doing is it's just saying, okay, 1990 was the first one that you entered in. And we're just giving that as like a number 3, because in terms of like the actual numerical value, that one is like comes third. So it's 1977 is the lowest number, 1983 is the second highest number, 1990 is the third highest number. And so it's just literally going to put those as like numbers, thinking you just want those converted into like sequential numbers. So that's why if you do that, it's not actually going to like recognize them as those like specific sets of numbers. Does that answer the question? You could also do another thing that works is you could do as.numeric and then as.character. Then that would also give you, yeah, so that would be as a, you're changing it into a character, but then you're changing that character into a number. If that makes sense. Do we have any other questions about this? Okay, so let's continue working with factors. If we just want to look kind of at the representation of females and males in the sex column of the surveys data frame, just to get a quick glance at this, we can actually plot this in a window. It's going to appear here. So if you tab your files, plots, clicked on my plots one. So I'm just going to type the plot function, and then I'm just going to say from the surveys data frame, I just want us to be looking at sex. Okay, and so then you'll see here on the, oops, in our plot window. So we, ooh, sorry. Okay, so we, oh gosh, I don't know why my plot windows moving independently. Okay, so it looks like we have slightly more males and then females in the data set. But we see that when we, if we do the summary function to just look at these, we see that we have probably about like 1,700 individuals that don't have, we just don't have information for them. And so we want to be able to show them in the plot. And in order to do that, we can turn the missing values into NAs. And so this is kind of going from the opposite end of what Courtney was talking about, where this one is, if you don't have, if you want to actually show kind of that data here. And so what you can do is you can do, let's within our vector here, we want to add an A. And so we want to add just a NA section here. And then if we look at, oops. And if we actually look at what we added, okay, so now we see that we added a NA down here. Actually, let me add this into the, I think it wants to go into the surveys and not just that vector. So let's do, so in order to do that, I'm just going to call the column within the surveys again. And then I'm just going to say add A. Okay, so now let's see if that. Okay, yep, so we have female, male, and then an A here. Okay. Okay, if we want to look at the, just like the first 6 rows, we would do that function that Janani was talking about, head. Okay, and so we see we have male, female, male, female. Okay, so say let's, instead of NAs, we actually want to give those ones an actual name. So we want to call them, say, like undetermined or something like that. We don't want them as just male or female or NA. And so what we would do there is within that level for sex, I want to go into the data frame here. We would say that third kind of category, we want to call that maybe undetermined. Oops. And again, I misspelled the data frame. It should be surveys with an S. Okay. Okay, so now if I look at that, if I look at that again, okay, so now we see that we have females, male, and what's called undetermined. Okay, and then if you wanted to look again, just to verify that we actually do have some of those undetermined ones that showed up. Okay, so we see that we have 3 levels there. Okay. Okay, so then if we plot them again, then we should see a third kind of data set come up in the plot. Okay, and so now we see that we actually have, well, mine came up as slightly 0, which is not right. Okay, so now we have this other kind of category here that's undetermined. Although mine came up as not showing, doesn't have any counts. So I have to figure out why that would be. If anyone wants to, any of our helpers want to jump in if I made a mistake. Does anyone have any questions about what we just did?
Just briefly like scroll up on the code that you have.
And then we do have someone saying that they have a weird column marked as nothing.
Nothing. Okay.
Like, I guess I'm assuming that means like a blank column, but correct me if I'm wrong.
Let's pull up here. Okay, so some people, I guess, are saying they have an empty column. Is this the column for the actual survey's data frame? Oh, okay, I see. So I guess McKenna, okay, so you're just not, it's like the name isn't popping up for the NA. Okay. Yeah, so in that case, let's go back to that. So if you would go back to that sex column for surveys, and then we want to add NA. And then try running this line of code that I just highlighted. And see if that works, I guess, for people that were having the issue that McKenna typed.
McKenna did say that this was before we did the NA.
Oh, okay.
And then Nicole said, after doing that, I get levels. When she runs levels, she gets the blank female FM and then NA.
Yeah, Nicole, that's correct. Good. Okay, so that's what we wanted. And then the next step of that was just to relabel the NA as undetermined. And so in order to do that, that is kind of the code that we had above. So within the levels for our surveys data frame and sex column, the third level of that, we want to label it as undetermined. Okay, so if you type this line of code that I just highlighted, that should then change that NA value into undetermined. So does that work when you do that?
I have like an NA and also like a completely like empty quotation space. So like I have 4 bars on my graph.
Interesting. Okay. That graph has 4 bars. Okay, and so then someone else.
Sorry, Nicole and McKenna, did you both use read_CSV or read.csv?
Oftentimes when I run into errors like this, I'll go back and start with like rerun the pulling in the data and start fresh, because sometimes you can just kind of repopulate an error and bring it with you.
And the reason I asked that question is because I reread the file using read.csv, and that gives me the blank F and M.
Oh, thank you.
Versus when I do read_CSV, it just is F and M. So that might be making a difference.
Yeah, and those two Cassie just put in the chat. So read_CSV is in, yeah, the tidyverse kind of package. But they will do slightly different things, even though it looks very similar. Okay, I think I will. Is everyone okay with me to just go on to formatting dates? You might just do that. This last part of the factors. Okay, so let's say that you're working with like date data, which is very common. You have a column where you just want to know like either when you collected it, or maybe it's actually not even part of the metadata, maybe it's part of like the actual data that you want. Okay, so if we just look at the structure here of that survey's data frame, what it shows down here in the console, we have all of this stuff. So we have month, day, and year here. So we have separate columns for month, separate columns for day, separate columns for year. And maybe we want to have that as like one column where it just has all of that information in it. And so we're going to use what's called the YMD year, month, date function. I'm not going to put anything in there. I just want to write out what it was first. And so in order to do that, we need to use a package that's like part of the tidyverse kind of library, and it's called Lubridate. So what you're going to do is, like Janani said, the packages, you've already downloaded them, or like equivalent of like you get them, but then you have to like be able to open them to actually use them. And so we already have the Lubridate package downloaded because it came along with the tidyverse kind of library, but in order to actually use it, we need to load it in. And so you're going to type library, and then the Lubridate kind of should come up. And then I think someone asked this before, when you're installing packages, you need to put the package in quotes. And when you're loading it in, you do not use quotes. And so you will just load that in. Okay, and now we're able to use that year, month, date. And so we'll just kind of I'll just show briefly how that works, and then we can actually like apply it to the data set. Okay, so year, month, date. Let's say I want to create something that's just called like my date. I want to do year, month, date, and maybe I want to, say like 2015, January 1st. I'm going to put that in quotes. And so the way that the year, month, date function works is you always go year, that should be like the 4-digit number of the year, hyphen 2 digits for the month, and then hyphen 2 digits for the date. And that's how it's going to recognize it. Okay, so I've created that object now. And if you just look at the structure of that object called my date that we just created, we see down here in the console, it says it's a date format 2015 January 1st. Okay. And you could also do this by, if you wanted to kind of paste the year, month, and date separately, you could do this by saying, I'll just say like create a new object called my date too. So you would use the year, month, date function. I'm going to say paste. And then within that, I want to paste 2015, 1 for January, and then 1 for the 1st of the month. And then outside of that paste function, I'm going to say these need to be separated by just a hyphen. And I'm putting it in quotes so that it knows that like I'm saying hyphen. Uh-oh, what did I do? Okay, and then sometimes I just got an error. It's because I didn't add another parentheses. Nope, now that's wrong. 2015. Oh, okay. So the parentheses was misplaced in the paste. Okay, so it should say year, month, date, paste, open parentheses, all of your information in there, close parentheses for the paste function, and then close parentheses for your year, month, date function. Okay. And then, so now you did the same thing. So if you look at your global environment, the my date and the my date too, those were 2 different ways to make that date. Both of them are correct. Just 2 options. Okay, so now if we're going to apply that to our surveys data frame, what we can do is we're going to create a character vector from the year, month, and day columns of that survey data frame. So if I just open our surveys again, we see that we have a column that's for month, a column for day, a column for year. And we're just going to create another column that just has all of that information kind of in one. Okay. So what we're going to do is say paste. And within our surveys data frame, I want to paste the year and then comma. And then I also want to paste the month. And then I want to paste the day. And then I'm going to say all of those should be separated by a hyphen. Oh, and I keep leaving the S off of surveys. Okay, great. So you'll see that at my console now it just like output all of the dates in there. And so now if we open our surveys again, there should be, I guess it didn't add a new column, but essentially what it did is it put all of those into one. So if you wanted to actually create like a new column where it did that, and you didn't want to just see the outputs, if you wanted to create a new column within your surveys, you could say, I'm going to create a new column. Maybe it's called like date combined or something like that. And then what you could do, I'm just going to copy and paste this because I just wrote it. Then what you could say is, okay, I want to create a new column that's like all of that date information combined. And then I want to paste all of that. So that should work. Okay, and so now if I open my surveys data frame again, it's going to be at the end. Okay, so here it's going to be at the, when you add a new column, it will just come at the end of the data set. And now I have a new column that says like, it's all of the date information combined, year, month, date. So that's kind of how you can do that. Does anyone have any questions about what we just did? Or did anything not make sense?
Looks like we're good.
Okay. And okay, let's see. Yeah, I think there's a few other things in the tutorial just of like if you run into errors. With that, let me see. Okay, but that's kind of, yeah, that's how to do dates and that's how to do factors. So I think I saved us a little bit of time. So I finished up a little bit before I thought I was going to. Okay, so someone says, how do you know the new column is pulling the year, month, and day from the same row, if that makes sense? Okay, good question, Gloria. So what that's doing here, when you're creating a new column, it's going to take all of, let me pull up the surveys data frame again. So what it's doing is if you want to do this for all of the data set, it's just going to say, okay, we're going to go through it for each row. So for row 1, I'm going to take the month, the day, and the year and combine those. And I'm going to do those for all of the rows. So that's how does that answer your question? Okay, good. Okay, Michaela's going to go over, I think the next step is, I guess we have a little bit of a break. Do we still want to take the little bit of a break, Janani?
Yeah, I think let's take a very short, just 2-minute break to allow everyone to decompress. In the meantime, I'm going to send you a link in the chat to download the file that we're going to be using for the final part of the workshop. So as you're taking a break, maybe stretching a little bit, also just make sure that your computer is downloading this file and put it in the same place as you put the first file that we were working with, just so that it's easy for us to find and load into R the next time. And if you can't access the file for some reason, let us know and we can maybe email it out to you instead.
And this next little bit is ggplot, which is everyone's favorite. So you're going to want to be ready.
I'm going to go walk around for a minute and then come back. We're just waiting on some people, but this is your 30-second warning if you're around your computer. Thanks for sticking with us, everyone. We know this is a really long workshop and coding can be really brain power intensive, especially when you're learning something new. So this is an impressive feat, sticking with us for 3 hours on Zoom. What's your dog's name, Michaela?
This isn't actually my dog. This is Courtney's dog, and his name is Tux. My dog is the brown one, but she's too big to be on my lap, and her name is Truffles. And then we're fostering a puppy, and we also have my other old roommate's dog here, Eli. So we have 4 dogs at my house right now, which is a lot. Most of me getting up has been like running to deal with some dog situation.
That's the perfect human to dog ratio, right? One is to
Yeah,
one.
4 people, 4 dogs.
Okay, Kendall's here, but her video is up. Great. Okay. I think we're gonna get started just in the interest of time because ggplot can be a lot, and I want to make sure we're able to give you at least an introduction. So just a quick reminder, if you're here and if you're able to turn on your camera, if you can't, that's totally fine. We just like to see your faces and know that there's other people in here with us. Okay, so show of hands, who is new to ggplot? Can you give me like a thumbs up if you're new to ggplot, if they're using it for the first time? Okay, 1 thumbs up. 2 thumbs up. Great.
You can also do the reaction thumbs up.
Yeah, exactly. Thank you. Okay, so there's a few people who are completely new to ggplot, which is great because I think ggplot can look very intimidating, but once you figure out the basic syntax of it, it's so easy and you can do so many things with it. So I'm really excited to be introducing people to this tool for the first time. So hopefully everybody got a chance to download that CSV file that I shared with you on Google Drive. It's called surveys_complete.csv. What I'm gonna, let me share my console again. Okay, there we go. So you can see me sort of experimenting with all of your questions about factors as Kendall was talking. And so what I'm gonna have us do is load in that file into our environment. And so we're gonna store it in this object called surveys_complete. And we're gonna do read_CSV. This is just where my file is stored. Use the correct sort of path or direction for whatever your surveys.complete.csv is stored. And then you should see that if you're using read_CSV, it should give you like a quick summary of all of the different columns and the types of data in each of your columns again, right? And in case you haven't done this already, make sure to load the tidyverse library in R, because ggplot is sort of bundled into this tidyverse library. And so ggplot should be automatically loaded for you. So the thing with ggplot is that there's a very basic template that we use for different types of plots. And I'm gonna put that in the chat. Chat. On the chat. There we go. So this is a basic template that you can use to format your ggplot commands. And so let's walk through that. The function itself is called ggplot. And what we're seeing inside the parentheses is how we sort of set up our data. So the first argument to the function is data. And that is just the name of your object or whatever data set you're using as the input for your plot. And then there's this argument called mapping, which I'm highlighting, but of course you can't see my highlight. Mapping equals AES, which stands for aesthetic, and the mappings. And we'll talk a little bit more about what the mappings mean as we start to generate our own plots. But some fundamental examples of mappings include what's going to be on the y-axis, what's going to be on the x-axis, do we want to color our plots, what do we want to color them by, and things like that, information that's going to be used to create the plot. And then you'll see that there is a plus and then geom_function. And that's telling ggplot essentially what type of plot you want. So ggplot can plot a lot of different things. It can do a dot plot or a scatter plot. It can do box plots. It can do line plots. It can do histograms. It can do so many different things. And you need to tell ggplot exactly what type of graph or plot you want for your particular data. And the way you do that is by saying plus geom_underscore line or geom_point, right? So that tells it what kind of data to plot. And let's actually try and put this command in practice so that I'm not just talking at you. So using that syntax, we do ggplot data equals surveys_complete. And so you can see that nothing happens because I haven't told it what to plot yet, right? What I'm gonna do next is create mapping goals. So I'm looking at my column specifications here, and what I'm gonna do is I'm gonna plot, say, weight on the x-axis. On the y-axis, I'm going to do the column hindfoot length. So we're seeing that R is processing, but still nothing happens because I haven't given it that instruction of plus geom what, right? Now what I'm gonna do is I'm gonna do something called geom_point. Second screen is obscured. Great. So now you see that something happened, right? We saw the scatter plot pop up in the bottom right window. And so as I instructed ggplot, weight is on the x-axis, just closing the chat, and hindfoot length is on the y-axis. So this is great. Something happened, but is this the best way to visualize my data? Oh, sorry, I was looking for an answer. Is this the best way to visualize our data? Does this actually give you any information, or would you organize it differently is my question.
You gotta know.
You gotta know. Okay, why no? What would you do differently about it?
Kendall says it could look prettier. And there was also a question about what is in Surveys Complete, like what does that data frame look like?
Yeah, so if you look, let me do a summary. And feel free to use those functions we talked about last time. So summary, head, tail to explore Surveys Complete. But essentially when I do summary, we can see the different columns over here. So record ID, month, day, year, plot ID. So Surveys Complete is a modified version of the data set that we were using in the previous section. So you'll see a lot of the same things. The columns have just been modified a little bit to make it easier for plotting. So we're working with the same data set essentially, right? And so I'm using this data set and I'm plotting hindfoot length with weight. I'm trying to see how the measured hindfoot length varies with the weight of the observation, which in this case would be an individual, an animal, I'm guessing. So yeah, as Kendall said, this could absolutely look prettier. And one thing we can do, so the first thing I notice is that these are all very dense black points, which means that I don't really get to see the full breadth of the distribution. I don't see how many points are on which line and so on. So what I'm gonna do is I go back to my previous command. So I have ggplot, this is the data set, this is the mapping. In geom_point, I'm going to introduce an option called alpha equals 0.1. And what alpha does is it controls the transparency of the points that are being plotted. So when I do that, there we go. So it becomes a little more transparent. And this helps me identify where most of my individuals fall. So the places of high density are where most of the individuals fall, right? So like this circle over here, hopefully you can see my cursor in this circle, versus before you realize that all of these points were colored super dense. The alpha was set at 1. And so everything just sort of overlapped with each other. But this is starting to help me identify some patterns and some trends in my data. What I can also do is add color to my data. So I'm doing the same thing again. I'm going back to my ggplot code. Under geom point, I'm going to do color equals blue. And you see what I did there? It's a string. Colors have to be specified in the double quotes. So when I do that, it's in blue. And this is pretty, but again, it's not super useful because the colors don't really tell me anything, right? It makes it visually appealing, but the colors don't tell me anything about the data. So the next thing I'm going to do is something called, instead of doing this, I'm going to start doing a mapping function inside geom point. So I'm going to use that AES the same way that we did inside the ggplot parentheses. And I'm going to say color equals species ID. So let's take a moment to figure out what I'm telling ggplot to do here. I'm asking it to plot these points. I'm still asking it to do weight on the x-axis and hindfoot length on the y-axis. I'm asking it to make the points more transparent. But this final line that I added, color equals species ID, tells ggplot that now I want these points to be colored by the species ID that they're tagged with, right? And so when I do that, okay, there we go. So that's much more informative to me because now that's giving me a sense for how the weights of different species are distributed, how their hindfoot lengths vary, and then the relationship between the weight and the hindfoot length, right? So I am going to pause there because we just did a whole run through of ggplot syntax, and I want to see what questions we have so far.
Janani, could you just describe why using ggplot function is useful? Like what are the advantages over using ggplot versus like plotting in base R?
Yeah, so plotting in base R is something I do for quick and dirty like X and Y plots. I just want to check how two variables look like. ggplot is really cool because it's very customizable. And the nice thing about ggplot is that with the same syntax that I showed you, if you just copy paste the syntax like somewhere on your work screen or on like a piece of paper, you can create so many different types of plots and you can customize them exactly the way that you want, which isn't always possible with base R. Or you might have to install a few different file packages in base R to be able to create different types of plots. But with ggplot, it's one package and you can create like dozens of types of graphs. Something we haven't talked about is also color palettes. You can play around with a lot of color palettes within ggplot. So if you want a custom color combination for some reason, you want to be able to tag the same species with the same colors, it just is a lot easier with ggplot, in my opinion. Anything else that Michaela, Cassie, or Kendall, you want to add to the glories of ggplot?
I would
It's
say
also part of tidyverse. Oh, sorry. It's part of tidyverse. So if you use those functions, they all plug in together. It's very useful.
and the language, the syntax used in ggplot is very intuitive and it's always the same. So whether you're making a box plot, a point plot, a scatter plot, it all uses the same kind of parameters, which makes it really easy to learn quickly what those are.
Yeah, I would also, the consistency I think is really helpful. Like I've just started making a bunch of maps and I don't work in ArcMap at all because I don't have access to it. And it's just nice to be able to make really pretty maps using ggplot. And someone said in the chat that the facet wrap and facet grid are really great, which if we have time, I'm gonna go over a little bit, and I use those all the time. Someone also mentioned that there's a lot of online resources. And I think that's, if you want to do something in ggplot, someone has done it and you can figure out how to do it if you're persistent enough.
And we'll send you some of those resources too after the workshop. There's a very handy cheat sheet for ggplot, which you look at the cheat sheet, you figure out what types of variables you have, and it tells you what type of plot you should be plotting, which is very cool. So as we were talking, I just changed up our command a little bit, and you'll see that I changed a couple of things. So over here, I changed the mapping aesthetics. So now I said, I want the species IDs on the x-axis, and I want the weight on the y-axis. And instead of using geom_point, I did geom_boxplot, right? And so you can see that I used the same syntax, I used the same data set, just different columns, but I created a plot that looks completely different. And we're looking at the data in a completely different way now. So box plots are great because they show us sort of a rough distribution of the data. What they don't do is show us the exact points that fall within that distribution. And sometimes it's helpful to see where the individual data points fall on these in these columns of the box plots, and what ggplot allows you to do. So for example, if I did geom_boxplot, but also geom_jitter, and jitter is just a different way of plotting the dot plots that we just did before. And I said geom_jitter, and I said color equals red. Yeah, and so there's obviously a couple issues, but first things first, we can plot multiple types of plots on top of each other. We can overlay plots on top of each other. So building a plot in ggplot is a very iterative process. You can keep customizing, you can keep adding. The more you do, plus geom this, plus geom this, you can customize your aesthetics and your mapping, and you can keep building on and on and on. So think of it as you have a base layer. So what we're doing with ggplot and mapping is your base layer. And then we keep adding more and more and more things as you keep sort of creatively building your plot. So the way I would improve this, first of all, is by changing the transparency of those points, like we talked about earlier. So if I did alpha equals 0.1, I would actually be able to see a box plot, for example, because my points are more transparent. So now I can see the individual plots, individual points, as well as the box plot underneath. And what I can do if I really want to see the boxes is the order in which you type things is important, because ggplot is going to plot them in the same order. So I created my base layer, then I'm going to plot my jitter points, and then I'm going to plot my box plot. And that is hopefully going to look different. There we go. And so this is what I meant by the layer on layer. You can see that the box plot is now clearly in front and the jitter points are at the back. So you can customize that however you want, but just sort of remember to think in that layer upon layer model, and remember that whatever you type first gets plotted first. Any questions about the box plot and the jitter? I also want to say that one more cool thing you could do with ggplot is, for example, sometimes we want things to be plotted in log transformation, and you can do that pretty easily with ggplot as well. And one final thing before I hand it over to Michaela, because there's so much going on. In terms of customizing things, let me go to the relevant section in my notes. So for example, if I wanted to add a title to my plot, I would say variation in weight by species. And then I would say X, and this would be my X-axis label. I would say species, which is a more polished way of saying species ID. And then my y-axis label is weight in kg. So, and there's a number of tutorials that will teach you a little bit about how to move things around, how to increase the text size of elements, and so on and so forth. I wish I had more time to go into that, but I don't today. What I am going to show you is how to save a plot like this. So there's a function called ggsave. Actually, before we go to save, we can only save objects from R, so we need to change this into an object, which is also good practice if you're building layer upon layer, because it might be simpler for you to save your base layer, so this ggplot data and mapping as an object, and then you can keep adding layers to it without having to retype the base layer over and over again. But for now, say I save this as an object that says my plot, and then what I want to do is say ggsave, the object I'm saving is my plot, and I want to save it as my plot.png. Actually, I got the order of this wrong because you want to type the name first, the file name first, and then the R object name. You can also specify how wide you want your PNG file to be. And then you can specify something called DPI, which is essentially the number of pixels or the resolution that you want your plot to be. And so when I do that, where it says it's saving the image, you see the little stop sign here that tells me that R is working on something. And then if I go to my desktop, you share, and you can see preview, and R saved the plot according to the width and the resolution that I asked it to. So I have so much more to tell you about ggplot, but we're also running out of time, and I want to make sure Michaela has time to cover some very important things. So I'm going to stop here.
Can everybody see my screen? Are we seeing the correct
Yes.
screen? You can see my R console. I have 3 screens, so sometimes I struggle with that. So I'm going to talk.
We can see, I think, maybe your desktop.
Oh no. Okay, I'll move it. Oh, sorry. Now you can see it. Is that correct?
Yep.
Great. Sorry, I get confused with all my screens. So I'm going to talk really quickly about, not super quickly, but about faceting and also themes, because there was some things in the chat about the ugly gray background, and the ugly gray background is one of my #1 pet peeves that I hate, and I think a lot of people feel that way. So first, I'm gonna, because I've been playing around with this a little bit, I'm gonna run this rm list equals ls command, and that just cleans the environment. It's kind of the same as this little broom over here. And then I need to load tidyverse. I need to load the data that Janani sent and I downloaded. And then we didn't really get the chance to go through what this pipe operator means, but it's a way of aggregating data. I actually don't use it that much because I like to work in base R. I don't really like doing everything in the tidyverse. But for the purpose of, hopefully not a bunch of dogs are going to start barking now, but for the purpose of keeping things going, you can just, I'll paste this in the chat and you can just, if I can find the chat, and you can just run it yourself. But now the chat, since I started sharing my screen, I can't find the chat. Show chat. Aha, I did it. Okay. So you can just run this as long as you have surveys complete. And basically, I will show you. So this command, oh, that I just deleted. I did it again. I'll just show you what the data looks like. So it's basically a data frame that has a column of years and a column of genera that have been counted. So what this does is it counts the numbers of unique year genus combinations. So now we'll make a plot with this. So I'm going to call in ggplot. The data is going to be what I just generated, this yearly counts. And then I'm going to use the aesthetics. The x-axis is going to be year, and the y-axis is going to be n, which is the number of counts. And then I want this to be a line plot. So I'm going to use geom, not blank. That's one of the things that can happen when you tab autocomplete too much, is you get the wrong things. And now I'm going to introduce this new thing, which is the facet wrap. And this is something that I use all the time. So I'm going to make facets equal to variables genus. And I'll run that. I'll run that and you'll see here in my plot panel, it'll take a second. Am I missing? Okay, so it just ran and then it should populate. And you can see now I have this graph. And so for each unique genus, that gets a panel, which can be really useful if you have data that's not aggregated and you want to show everything and you don't want to make different data frames for everything. So now we're gonna just show a little bit more about how we can customize these facets. So again, you'll have to run this command to get this new version of the data. So this is just doing a new count like the one above, but it's doing it by year, genus, and sex, because now we want to customize this a little bit more. So we'll write ggplot. The data is going to be yearly sex counts. The aesthetics are going to be somewhat the same. X is still going to be year, Y is still going to be N, but now we have a color variable, which is going to be sex. And then we still want this to be a line plot. Oh. And we're going to use the facet wrap again. My computer is a little slow because it's doing a lot with the zooming and the R-ing, and it's not that great. So now you'll see that we have it's a little bit big for this area, so I'll show you it zoomed. So now we have a facet for each of the genera, and then we also have sex overlaid, but you can see that there are two colors for that. So that's a way that you can show multiple variables. Are there any questions on that?
I think we're good so far.
Okay, so now we're going to make it even a little bit more complex, and we're going to make facets by, let's say you want to look at sex and genera. So we're still having year and Y is still N, color is sex. So now we're going to use the facet grid because we're going to have it faceted by multiple things. So the arguments here are rows. And so for the rows, we're going to have it be sex, and then The calls are going to be the genera. I'll probably have to make this big again too, because it's probably going to be too small for my interactive viewer once it finishes. And so now you can see we have the counts on the y-axis, the years on the x-axis, but we have panels for both. The columns are the genera, and then the 2 rows are the different sexes. So if you want to show things separately, that's a way you can do that. I find that when I get to that many panels, my eyes glaze over and I can't understand anything. Okay, so now we're going to do one just with rows. So we're still doing x axis equals year, and the y equals n, and color equals sex. And now we're going to use facet grid again, but this time we're just going to have the rows equal genus. And it's going to take forever because my computer is slow. And yeah, someone put in the chat, and this is actually how I normally do this. You can also just write facet wrap like that, and with a tilde equals genus instead of having like facet wrap written like that. And that's what I normally do. But when you're learning, it's really good to write things out verbosely so that you know exactly what you're doing and you're not getting confused. But here you can see now we just have sex and both colors on the same, this isn't really loading, both colors on the same plot, but the facets are rows of the different genera. And we can change that to columns just by changing this argument to calls. And then we're going to talk about themes really quickly. There's so much more we could talk about with ggplot, but we're really running out of time now. And this is just kind of a quick and dirty introduction. So here you can see now the genera columns again, and both sex colors are on the same plot. So I absolutely hate the gray gridded background. The easiest way I think to get rid of it is just theme black and white. And that's if you still like having a grid. And so you can see I just did that. I just put a plus in case you weren't tracking where I was. I just put a plus here and added theme black and white. So that will make the background white, and it will still have the gray grid lines. Some people really dislike the gray grid lines, and there's other ways you can make your own themes, which I think some people were talking about in the chat, but there's also other theme options. So here you can see what this looks like if it will load. Yeah, so you can see this is white with the gray grid line still, but it's a little bit more minimal. And then there's also theme minimal. And there's quite a few themes in my notes that I have here. The 2 other ones that it's suggesting to look at are theme light and theme void. So we can look at those, and there's a lot of other ways you can customize things. Pretty much if there's anything you want to do, you can find a way to do it in ggplot. Some are clunkier than others. I don't think I've ever seen this theme void, so I'm kind of interested to see what it looks like. Oh, wow, that's like this is just like if you want something really stylistic with no axis labels or numbers. So yeah, that's just a quick overview. You can use this. You can also just use the basic theme command here like this, and then there's a whole bunch of arguments you can put in there to adjust backgrounds and axis labels and things that, or not axis labels, but how the axes look or if they're present at all. And there's a lot you can do with that. And I think that that is all I will go over unless, are there any questions?
Someone asked, can you explain the pipe function? We talked about two kinds of pipes, I guess. So
yeah, I can go over it pretty quickly. It might be, I don't use them that much, but I do understand them, so I can talk about them. And if somebody wants to chime in and be like, this isn't how I would explain it, go ahead. So here, I'll just load the data and you can see, I'll run, make this a little bigger so people can see it. I'll run ahead on Surveys Complete so you can see what that looks like. So Surveys Complete has 13 columns and 3,463 rows. So this yearly count, what goes first is the data frame that you want to aggregate in some way and make different. And then this pipe operator is basically saying, okay, now I'm going to tell you what I want you to do with this data frame. And then I'm giving it the command count, which will count the records. And so then I'm saying, I want you to count it by year and genus. So when I run that, we can look at head yearly counts. And now we have a data frame that's just year, genus, and then these count numbers of the unique combinations of year and genus. And so another way that you could do this in BASER is you could do yearly counts, and then you could use the command aggregate. And on one side of that, actually, I don't know how I would do this here. There are other ways to, I won't get into this because I think it'd be a little bit more confusing because it wants you to count, but there are ways you can do it in BASER without these, without this operator. Basically, if you ever want to take a mean of something, aggregate's a really great way to do that. And you can put one thing, you write it out like a formula.
I will say that I use the pipe function, the percentage sign with the caret in the middle, and then the other percentage sign quite a lot because I like doing kind of like minimalist coding. And so the one thing that the pipe kind of allows you to do is it basically, I think Janani put this up in an earlier comment, is that you can use it to just say like whatever occurs before the pipe, essentially whatever occurs after the pipe, you will just like format it to whatever object you put before the pipe. So it's just a way to just reduce like the amount of code that you're actually writing. Instead of doing like the data frame and then brackets or something like that, you can just say like data frame up top at the front of the code, and then whatever is after the pipe, I want you to do all these things to it.
Exactly. Yeah. And I think actually in this situation, I probably would use this pipe instead. I like to try to do things in BASER as much as possible, just because it's like, I don't know, it never changes, which is nice.
So it is 3 o'clock. I know I can hang around for like 10, 15 minutes if people want to talk or if you just have any remaining questions. But otherwise, the workshop is officially at an end. I am going to throw a link for a post-workshop survey in the chat. We'll also send you an email with some more resources and the survey. But please fill out the survey. I would really like to know how we did.
And we'll also send out in the email the like data carpentry kind of tutorial that we used. And so if you want to kind of go back through what we did, the tutorial describes in kind of detail a lot of what we did. And so it'd be a nice thing to just, if you have time, to go back and look at that. So we'll provide that in the email as well. Yes, and we are going to email out the recording also.
Thank you.
Thanks for coming, everybody.
Yeah, thanks everyone for joining.
I have a meeting, Janani and Michaela, so I'll just make one of you the host. And then once I think once the meeting ends, or maybe once I leave.
I think
or-
it's
Yes,
might
depends.
just be us left. I also have to run to a meeting in about 5 minutes, but I can hang out for 5 minutes.
Natalia, do you have any questions?
Maybe they walked away and
Yeah, they
forgot
might
to
not be
exit.
here.
Well, we could just end and then this will like automatically download to my cloud and then I'll deal with that.
Sweet.
Could I just send you a couple links to be put into the email that we sent out, the survey, but also a couple
Yeah.
of links for like color palettes and stuff.
Yes.
Do you
This
think
was awesome though. You did such a good job.
that was great, Janani?
I'm so glad. I felt like we went super fast in the end, but
No, I think it's gave people a taste. I think that's one of the things with coding. It's just nice to be able to have someone to just like introduce you to it,
yeah.
and then it allows you to be more comfortable like playing with it on your own. I think.
I agree. And I think by sending people the materials too, then they can go through it themselves.
Is it worth saving the chat? Because if so, we would need to do that now. Do we want to do that or? I don't, my instinct would say no, but I don't know. Is there an advantage to?
I think if we have the recording, and I think it'd be awesome if you're able to get that like participants list just for our own purposes after the fact. It'd be great to have just to know like how many people were here and how many came and gone and stuff like that.
Awesome. I think this was a big success. I think it worked out really well also with all of us being able to like,
Yeah.
answer. I didn't feel personally overwhelmed trying to answer questions. And when I think
This was a good number.
Yeah, I agree. And it was nice that whenever I had puppy emergencies, I wouldn't feel like no one was going to answer the questions in the chat.
No, thanks for letting me do this. This was so great.
Thank you for volunteering. We are feel indebted to you. I really appreciate it.
I'm excited for the next workshops. I'm excited to learn more things.
Yeah.
Yeah, and we might have I think we'll just have a different audience because I think it'll be people that are a bit more experienced and yeah, I think it'll be interesting.
Great. Well, oh,
Great.
you left. Great. I'll see you both at a meet and greet, hopefully.
Yeah, maybe we can also I can send an email and maybe we can just have like a little debrief about this
Yes.
later if you have time and availability.
Yes. No, that sounds good.
And
After we get in hopefully some
maybe the
feedback.
survey and stuff like that, we can talk about it and think about
Yeah,
like what we liked and what we didn't like and that
Yeah.
sort of stuff.
So Janani, why don't you send the resources that you were talking about? Why don't you just send them to the WISE email?
I'll do that.
Cool.
Great. Okay.
Awesome. Bye. Thank you so much.
Thank you.
Good rest of your days.